Very quickly, before I turn things over to Stephen and Sujit, I just want to take just a second to introduce the Mist product line to you and just kind of help you understand where all these different pieces fit in here. So at the very top of kind of the pyramid of products here is the Mist Cloud. And this is the core of everything that we do. First off, the Mist Cloud is built on a microservices architecture. And that allows us to be really agile and very flexible. For example, we do a production push every single Wednesday where we can swap out microservices to introduce new features. And so as a sales engineer at Mist and Juniper, this keeps me on my toes because there's always new things to talk about. There's always new things to show customers. Now, the Mist Cloud is also built from the ground up to support AI. It's built for data sciences. It's built for machine learning. And so we are able to we're able to lean very heavily on the Mist Cloud and the essentially unlimited processing power that we have with it to perform a lot of these complex functions. Now, everything that we do is offered as a service, and so we have a variety of cloud services that are available that you can purchase to basically enable certain features to do certain things on the network. Like for example, later today, Sunalini is going to talk about contact tracing and how we leverage user engagement and asset tracking to do that. Finally, we have but we also have a complete wireless infrastructure offering. This is what we've been doing for a very long time. We're very excited that we now have a full 802.11ax product line or Wi-Fi 6 product line. Me personally, I'm the most excited about our new AP12. It's a wall-mounted hospitality access point that has a 3-port switch built into the bottom of it. Love a little AP like that's very, very useful in places like college dormitories and hotel rooms and things like that. Today, we're also going to talk about how we are integrating the wired infrastructure into the Mist Cloud. Both Abhi and Sujit are going to talk at length about EX switch integration and what we're doing there. And we're also going to talk about some new announcements today around SRX integration and how we're integrating the WAN infrastructure to the Mist product line. And so now with that, I'd like to pass things over to my personal friend and colleague, Stephen Cooper, who is our Mist AI specialist in Australia. Go ahead, Stephen.
Thanks, Joel. Thanks, everyone, for joining. So let's take a look at how this looks from an architecture perspective. So we've obviously started with Wi-Fi, as Christian and Joel mentioned, AI-driven Wi-Fi. We extended that into the wired network. So we're supporting the Juniper EX switches to get that rich telemetry from Junos into our microservices cloud architecture. And you would have seen probably back at Mobility Field Day also where we showed zero-touch provisioning, configuration management of the switches in the cloud. Sujit is going to show you a bit more about that and how that works, which is really exciting. And you can see here we support multiple switches, virtual chassis, as well as what Abhi and Sujit will be talking to you about, WAN Assurance and integrating the Juniper SRXs. And from a high level, this is this journey that we've been on. I'm sure some of you have seen this previously when we've presented. The theme is all around getting great quality data into our microservices cloud architecture from our access points and from our switches and the SRXs. And that all formulates our AI primitives in the cloud around monitoring and measuring the end user experience end-to-end across wired, wireless, WAN, the entire network architecture. That then feeds into our data science toolbox where we perform machine learning, advanced algorithms, and some real AI solutions that we're solving with wired and wireless networking problems. That also lends itself to Marvis, our virtual network assistant. Now, Abhi's going to show you exactly what's happening with Marvis and the new announcements that we have and where Marvis is going, and essentially setting ourselves up for the self-driving action framework, where Marvis is the extension of your network operations team and bringing you to a self-driving AI-driven enterprise.
Awesome. Thanks, Stephen. Now, one thing I just want to highlight while we're taking a look at the screen and while we're thinking about the journey that we've taken to an AI-driven enterprise is that one thing that we lean very heavily on is our AI primitives and event timeline. One thing that we're able to do is collect a lot of telemetry and form those into what we call service level expectations. Stephen's going to demo these for you in a minute, but service level expectations are essentially a measurement of the client experience. What's the actual experience like for the people that are using the network? And the primary goal of those service level expectations is to not only help us understand what the client experience is like, but also for Marvis, so that Marvis can help us understand what is going on with our network. So with that, Stephen's going to give us a quick demonstration of the wireless service level expectation and how we use those in AI-driven wireless.
Great, thanks, Joel. So here we're looking at our wireless assurance dashboard, our wireless assurance view of the world. And these are our service level expectations from a Wi-Fi perspective. Essentially, what we're aiming to do here is solve what are the two most common Wi-Fi problems. Users will report that the Wi-Fi doesn't work, and that means they either can't connect to it, they can't see the SSID, their pre-shared key is wrong, or they're not getting an IP address, or they can't resolve DNS. But essentially, to the end user, the Wi-Fi doesn't work. And then the other main problem is, the Wi-Fi's working, they can connect, but the experience is poor. So Wi-Fi sucks. And that could be anything from RF and Wi-Fi congestion, capacity issues, upstream networking issues on the wired layer, as well as what we're extending into WAN assurance, across the network and with application performance as well. So essentially, these service level expectations, all these metrics that we're monitoring here around time to connect, coverage, throughput, capacity, we allow you to customize and set these for your specific environments. And you can set what your target for success is. So connecting to the Wi-Fi, getting an IP address, being able to use the internet and applications, target at the moment is set to 2 seconds or less. Just like with coverage, we get a live real-time heat map view of every client, every user, every minute on the wireless network. We're measuring the RSSI, uplink and downlink, and we can set the target for success of that. For negative 66 dBm, for example, if you're wanting to do, high density data as well as voice grade Wi-Fi coverage. So all of these metrics feed into this. As Joel mentioned, we're leveraging this not only from a wireless assurance for troubleshooting perspective, but it's also being fed into Marvis, and Abhi will talk a bit more about that later. But it's also feeding into our cloud services, such as AI-driven radio resource management, where instead of just making changes to the radio channel allocations and transmit power on a finite-based time period and limited information, we're actually considering Wi-Fi interference, non-Wi-Fi interference, client count and usage and the capacity service level expectations, as well as what the actual SLEs or the end user experience has been over the past time period. That is all then fed into our radio resource management algorithm to then optimize the radios to improve the end user experience. So we have this closed feedback loop that's happening all the time to actually optimize the end user experience, which is extremely game changing and makes our radio resource management algorithm probably one of the best in the industry. Now, what I want to show you is just a quick root cause analysis of what we're doing here, and then we'll hand it over to Sajid for a look at the wired side as well. But essentially, if you're proactively looking at this and going, okay, well, I can see time to connect is 78% successful over the last 7 days. That means we've got 22% of our users are not actually meeting that 2-second target to connect successfully. Now, why is that? We can see some of those problems are related to association. Some of those problems are related to DHCP. So let's dive in, go into root cause analysis, and look at the information that our microservices cloud is presenting us. We can have a look at the timeline of when these issues are happening. So we can do network rewind or network time travel and see at this particular point in time, there were some issues related to association as well as DHCP issues. We can even see these values in percentage measures, even the number of failed attempts, and even the number of users that are impacted. And even if we go into DHCP, we can drill down further into DHCP stuck and unresponsive and things like that. I'm actually going to take a look at association, and then not only do we have all of this information at our fingertips over time, we can see if there's been any system changes or configuration changes that might have impacted user experience. Then we get into the power of what we're doing with machine learning and mutual information with Bayesian inference in the cloud. We're giving you some correlation factors of who is having the worst experience for what reason versus who's having a good experience. And we can categorize this for different device types. We can see the Mac operating system or Mac devices are having greater correlation of failure compared to iPhones. We can then drill down and say, okay, operating systems, Android Q is also having some failures. If we were looking at interference or capacity issues, we would be seeing, typically failures related to 2.4 having a greater weighting or correlation of failure. This is really powerful to see some context around where issues might lie. And this is all providing the administrator or the service provider visibility into, is it actually a Wi-Fi problem or is it something else that's causing this bad experience? Lastly, we can drill down into these users and access points and applications that are actually experiencing these failures due to association issues. We can see Denali and Everest and Cush's Galaxy S10 are the top 3 failing devices up here for association, and we can actually click on that to get to the root cause analysis summary of the top 1, 2, or 3 problems that we have detected in our cloud, and we call it out in plain English, and we say the client was slow to connect, due to slow association, and we've given you the blast radius. It's client specific in this instance. This means there's something happening related to this particular device, not actually something happening on the Wi-Fi, nothing happening on the RF, nothing related to a DHCP server that's failing. It's actually client specific. Same with roaming issues. We've detected that this client is actually having some roaming problems as well. Whether the user reported that to us or not, we've got that information there, and we don't have to dive through a needle in a haystack sort of view trying to find these packet captures and look at frames to then detect any slow roaming issues across multiple access points. We do all that for you. And the power of that is shown by our dynamic packet captures. So we automatically stitch dynamic packet captures together across multiple access points to follow clients as they move throughout a wireless environment. And all of these events, all of this data that's being fed into our microservices cloud, over 150 different states of users connecting to, associating, authenticating, authorizing, and consuming Wi-Fi. We're monitoring all of these for every user, every minute, and these are then feeding into our event timelines if you want to look at them. You can see over the past 7 days when these issues have happened. We don't need the users to be exactly specific as when it happened. Maybe it happened last Thursday at 2 p.m., but we've got the data at our fingertips here. We don't need to get the users to try and recreate the problem. We've got everything there to help them solve that problem. And if we need to, we can look at these dynamic packet captures to get greater detail. If we want to go into the specifics of these events, we've got all that information here at our fingertips. So truly powerful, and this is the power of what we're doing with our microservices cloud. And later on, Abhi will show you how Marvis makes this even simpler with leveraging our virtual network assistant capabilities. So with that, I'd like to hand it back to Joel to segue into the next section.
Perfect. Great. Thanks for the demo, Stephen. So now I'd like to introduce our next presenter, who is my good friend, Sujit Ghosh. He's our TME at Juniper, and he hates it when I say this, but he's also our resident EX switching expert, and he's going to tell us all about wired assurance.
Thank you, Joel. Very happy to introduce wired assurance on the Juniper EX switches. So we are at the stage of introducing the full portfolio of wired assurance, starting with how we are going to manage day 0, day 1, and day 2 activities. Day 0, we are now adopting our EX switches. So all new switches coming out of manufacturing do have a claim code on it, as we had in all our missed access points. Now, the same procedure we're going to follow for all our EX switches. So now we will be able to adopt those switches by entering the claim code or some adoption code. And I'll show you that in a live demo. As well as we have hundreds and thousands of switches all over the world, which also can be added to the Mist cloud. As long as you have the right software and connectivity to the cloud, you will be able to adopt those switches, which we call our brownfield environment. So that's day 0. As far as day 1 is concerned, we are talking about configuration. Even though we call this as day 1, you can always do these configurations well in advance via templates and keep it ready so that when you get a switch, you will be able to plug in the devices and bring it online in a couple of minutes. Even though we call it day 1, but all of this can be done well in advance in the cloud so that you can really have a plug and play environment. And along with that, I'm really, really excited to introduce for the first time talking about color and colorless ports. This is something which we are introducing on the Mist cloud, and I'll talk about that in details in the next slide. But at the same time, you have the option of creating these port profiles and associate them with different types of devices. It could be your IoT devices, your cameras, or your desktops, or your printers in the network, and assign them statically or do an auto provisioning of it on the templates, from the templates to the switches. And then continuing on the journey for the SLEs, as Stephen Cooper talked about, we are adding new SLEs for the wired network. Example, throughput, successful connect, switch health. We will have AI-driven insights into the health of the switch. That means monitoring the CPU, temperature, memory, and giving you those alerts well in advance, saying that there's something going on in the network you should pay attention to over here. And my favorite is the switch events and correlation. This is where you can go in and see exactly what is happening on the cloud pushing those configurations to your switches. What is happening on the Junos level, all your commands that we are pushing, all of that comes under the switch event, as well as the system alerts. And finally, we have Marvis Virtual Network Assistant also for wired. And Abhi will go through that in detail. But when you are deploying hundreds and thousands of switches in your network, hundreds and thousands of ports, it's impossible to track if there is a particular port which is misconfigured. And it could lead to a security incident. With the help of Marvis Actions, we will be able to now track those ports. If there are certain missing VLANs for a particular AP, we will be able to track those. And bad cables, bad optics, we will be able to do those detection well in advance. So we can tell you that something is going on in that port, something is coming up, looks like we are having some mismatch. We will be able to warn that to you before your users start complaining. It's all about giving an experience to those users, giving a very good uptime on your network. So that's where we are heading with wired assurance with Juniper EX switches.
Perfect. Thank you, Sujit. Thanks for the introduction. So you're going to give us a demo on what it looks like to do switching with the Mist Cloud?
Absolutely, yes, Joel. So I'm going to turn over to a live system which we have. We has a couple of APs connected and switches as connected to it. So I'll walk you through all the demo. To start with, again, I'll talk about day zero, which I mentioned about. So if you go under the inventory of our devices, you will have two options over here. For example, one is called the claim switches and the other is adopt switches. Claim switches is basically where you are having a new switch which has come out of manufacturing in the last couple of months. You have a claim code on it or a QR code on it. It's the same as we have done for access points. Or if you have ordered, say, hundreds of switches from manufacturing, you will be able to now add an activation code and enable all those switches in the cloud. And once you do that, you can assign it to a site. In this case, I'm assigning to a site of primary site. And you have the option now to do the management of the switch. So that means you will be able to push configurations from the cloud to the switch. But if you don't want to do that, you have the option of always disabling it and enabling it later if you want to. If you just want to monitor the switches to start with, you can uncheck that. That's what we are calling for a greenfield environment. But as I said, you have hundreds and thousands of switches in the world. We have been doing switching for many, many years. So as long as those switches have the right software version on it and can talk to the cloud, you can copy this 8 lines of configurations from the cloud and put it onto the switch console, and you will be able to make all your switches connect to the Juniper cloud. This is simple as that to bring in all your devices online. So that's what we are talking about, day zero activity. And this enables ZTP at the backend. And with the help of ZTP, you have the switches all part of your Mist Cloud. Then let's talk about day one. Again, as I said, it is day one, but at the same time, this could be a day zero activity. Before you receive your switches, you can go in and do some configurations. So we introduced the concept of switching templates. And this switch templates are associated to your org. That means all switches in your network will have these configurations. For example, you have 2 radius servers. I have one with the 192.168, and I have a second radius server, which is a jump cloud radius server. I'm having an NTP server in my network. I have some CLI configurations. For example, I want to add a username and password in my name in all the switches in the network. And I want to add some additional CLI commands if you want to do that. Then comes the shared elements part of it. This is where we are introducing the VLANs and the networks in your network. So I have added 3 VLANs over here: a camera network, corporate network, and an IoT network mapped to VLAN 20, 30, and 40. And at the same time, we created these port profiles. Port profiles is basically for different types of devices which is coming in your network. Let's look at the camera device in this scenario. So the camera device is actually an access port. PoE is enabled on it. It mapped to a VLAN of 30, as well as we have made sure that it's mapped to a camera network VLAN over here. So similarly, you will be able to create a port profile for corporate device. Corporate device is also an access port, and we have mapped it to a different VLAN of 40. But we have enabled 802.1x authentication for this particular port. And we have enabled PoE on it and STP Edge on this particular profile. And finally, we have another profile for missed APs along with it. Missed AP is usually connected to a trunk port. And in this scenario, what we have is we have configured it as a trunk port, and we enabled PoE on it and allowed all the networks as part of that VLAN. So the final step on this process is now what we call as rules. That means if you have different models of switches in your network, you will be able to create multiple rules and say that, for example, I have an EX2300 switch and I have assigned it with a role of access on it, and I can push certain configurations only for these switches. For example, if I want to do a port configuration on this switch, saying that missed APs are going to be part of port number 4, 5 is IoT device, and 6 is corporate device, and 7 is a camera device, I can push these configurations to all EX switches in my network. So this is a template which you can create on a global level, an org level, and you can override some CLI configurations for these devices if you want to. Okay, so that's the configurations which we have for the switches. Now, if you want to override certain configurations on a site level, that means your branch, for example, I have a primary site, it is associated with the same template, and you can see that all the configurations we have done at the global level is inherited over here. You talked about the radius servers, the NTP servers, the CLI configurations, everything is inherited. But if you want to override that, you can do it. Similarly, you can see all the networks have been inherited, profiles have been inherited, as well as the switch rules has been inherited. But again, you have the option of changing those configuration on a per site basis. In my example, I have not made any changes. I left it as it is. So now, when we added a couple of switches as part of this site, so if you look at my site called primary site, I have a couple of switches on it. Let's look at the EX2300 switch I was talking about. And you can see now clearly it has inherited all the configurations. The configuration is managed by the Mist Cloud. You can see the radius server informations. You can see the port configurations, the port 4, 5, 6, and 7, which I configured with multiple profiles. They have been inherited. But if you want to override them on a per switch level, you can do that. Similarly, you will be able to see the port profiles, which we created at a global level, the camera, corporate devices, and also the networks. And also at the same time, we have give you the option of CLI commands. So that means in this case, I wanted to convert this switch to act like a layer 3 switch. I enabled certain commands to do that. But that's optional, absolutely optional. You will be able to perform all of these functions directly from the Mist Cloud. But I just wanted to show you an example. So now this particular switch is completely managed by the cloud. But this is a very interesting section, which is the switch insights. So switch insights basically gives you all the details, what is going on with switch. So in this scenario, I have all the switch events coming up over here. For example, every time we push a config, did the commit go through? This is the place to look for it. At the same time, you have all the information related to your CPU, memory, as well as the bytes transferred and the power drawn in the switch. Power drawn is very important. You don't want to oversubscribe your switch with a lot of APs and run out of So in this scenario, we will be able to get, and there is a timeline view of it. As Stephen showed you, over a period of time, you can see the multiple events happening and correlate all the activities on it. So that's a very quick look at what we are adding as part of wired assurance. But at the same time, as I mentioned before, that we are going through the same process of adding SLEs for throughput, for wired, which includes throughput, successful connect, and switch health. And throughput has multiple subcategories on it, including monitoring your uplink congestion, storm control, network in it. The network basically tracks how is the cloud talking to your EX devices, how is the connectivity in it. Successful connect, if you have enabled layer 2-1X authentication on your switches, we can monitor those. We can look at your DHCP connections and also your switch health, which is very basic, but it has a lot of impact on your network. So these are some of the new SLEs we have added for wired network. But as I said in the beginning, I was very excited to introduce to you the colorless port scenario, or what we call as dynamic port profile. So as I showed you all the profiles that were created for the APs, the cameras, and the devices in the network with various configurations on it with an access and a trunk port, what I showed you till now was a manual provisioning method of assigning those profiles to those ports. But today, I am really excited to introduce this auto provisioning method. Even if you have a radius server in your network or don't have radius server in your network, via LLDP, we will be able to look into the device characteristics and create those various profiles and assign them automatically. So you can have a port which is configured with a default profile. As a result, it can not communicate anywhere in the network, but as soon as you plug in devices, they get applied with the right profile. Let me walk you through a quick demo of the dynamic port profile. So in this scenario, what I have is a similar template, which I showed you. I have my radius servers information. I have my networks created. I have created a network called restricted. And by default, that restricted network is applied to all the ports in the network. PoE is disabled on it. But we created these dynamic port configurations where we can look at the LLDP information or the radius information. In this case, I'm looking at the MAC address, and I can apply a AP profile. So as soon as a missed AP shows up in my network, I will be able to say that on this ports 01 and 02, I will apply those profiles. And this is applied to my site. I have a couple of switches as part of the site, but I have a 2300, and you can see that I have inherited all the configurations, including the restricted configurations and the restricted device profile. I inherited the dynamic port configuration, as well as now, by default, the configurations in the ports is restricted. But as soon as I plug in a device, it automatically updates that profile and says that now it's a missed AP connected to it, and it is configured as a trunk port with multiple VLANs around. So that's a quick look at our wired assurance, and also a quick look what we have for our full portfolio.
So what happens when you disconnect that device?
When you disconnect the device from this, it will go back to the original profile. So initially, I had a restricted profile associated. So that is the permanent profile which we have on that port. So as a result, you will get to this VLAN where you'll not be able to communicate anywhere in that world. So as a result, it will be kind of a security in your network so that you have zero communications on the port. Until unless you again plug back your AP, you will not have any communications on it. So it goes back to the original profile characteristics it had, Ivan.
Oh, that's great news. Thank you.
Okay. So final thing I wanted to quickly touch on is what are we doing for our SRXs? So I have an SRX over here imported into my Mist Cloud. So this is an SRX 320, which we have. And At the same time, it has providing all the information and also similar type of what we call as gateway insights. Gateway insights, including the control plane, CPU, data, memory utilization on it. And Abhi will go through all the details of this in the next session, but I just wanted to introduce the WAN assurance over here and the single pane of glass. So now you can monitor your APs, you can monitor your switches and your SRX devices from the Mist cloud, which introduces what we call as the single pane of glass.